So today we're going to do the circle lab, and I'm making this video to help people, especially if you're doing it at home, and also to get a little practice recording the videos. So you're going to first thing need the circle lab paper, and that's page 1 of the lab book, and I have a link to that on the Google Classroom. So we're just going to need to print that out. Now let's talk about overall what we're going to do. If you're at home, obviously you don't have access to lab equipment. But the nice thing for this lab is you don't especially need it. All you need is things that you have around the house. You need circular things. So you could use maybe a small plate. You could see here's a lid from a cottage cheese container, a yogurt cup, top of a pill or a vitamin bottle. I mean, we all have plenty of circular things around the house. I wouldn't go too big. You could use a dinner plate if you really need to. But I'd use the sizes that I have here. Now we're going to be doing some measuring. If you have a metric ruler at home, and you might, that's great. If you don't, what I've provided is a printable ruler. And this prints out pretty nicely. It tries to get it nice and long so it prints it diagonally. And you can hopefully just have access to a printer and print it out. Worst comes to worst, you can certainly use, a measuring tape or carpenter's tape. 1 inch is 2.54 centimeters. So if you're measuring in inches, you would need that conversion. So what I would do with this ruler, and I already did it before, is just take it and fold it. Just fold the paper. You could cut it out if you like. I don't think you necessarily need to do that. And there you go. Now you have your ruler. So what we're going to do is we're going to measure the circumference. So how are we going to get the circumference here? We can take a string and go all the way around, just any old piece of string or yarn. You could even use, like, if you have a necklace, I'd be careful with it. Obviously, I don't want you to break a piece of jewelry. But, if you have a cheap necklace or something or a lanyard, and you're going to go all the way around. And I would put my finger there. Now we can take that length of the string. Mine's actually a little bit longer, so I'd have to measure it out and measure it with the ruler. One thing to point out with these rulers is the 0 is not at the edge here. The 0 actually starts a little bit further in. Most rulers are set up that way. I think the reason for it is so when they're cut by the machines at the factory, they don't want the 0 to be right at the edge in case the machine cuts it a little bit funny. Now, if you're having trouble and you don't have a piece of string handy, something else you could use, maybe I'll do this one with the yogurt cup, is just cut a strip of paper. This is just a tiny little strip of paper I just cut off from a piece of printer paper, and you can use that to go around the edge. You can even mark it with a pencil or a pen if you want, and then you would easily be able to get your circumference. So you'll get your circumference and you'll write that down. Now, and I don't know how well you're able to see this, we have circumference in centimeters, and we could do the whole thing in centimeters. And then diameter. Don't use pi. We're not using pi. We're actually physically measuring the diameter. So we would want to put the ruler on this. And there might be some, estimation because it might be hard to see where the center is. One thing that I would look for is, and you probably can't see it on the camera, but a lot of containers right in the center, there's like a little bump. I think it's from where the mold was in the factory. And you can use that to get your exact center. And I would get that this looks like 12.10 centimeters, and I would write that down. So you're going to need to do this for 5 different shapes. So you might be able to find 5 different things around your house that are circles. I'm sure we all can. I'm sure we all have things that are circular. And one thing you can even do is, like with the yogurt cup, you could use the top as one circle, and then it's always smaller on the bottom, and you could use that for your other circle. And cottage cheese containers, cream cheese, butter containers. There's a lot of different containers that are like that where they taper to the bottom. You could use a mug or a drinking glass. Any of those kind of circular items would work. If you want to, you could even trace them onto a piece of paper if you prefer, and then use that for your circles. But don't calculate circumference. Don't calculate diameter. That's why I gave you a ruler, because I want you to measure it. Now, what we're going to do is we're going to now take a look at what do we do with all this data.
So let me now show you what we're going to do with the data. So what I did was I copied just part of the lab paper right here, and I'm going to go through it piece by piece. So the first thing we're going to do is we're going to draw a graph of circumference on the y versus diameter on the x. Now, I'm going to ask you to use graph paper, of course, and I'll provide a link to some printable graph paper in case you need it. One thing you want to get out of the habit is drawing graphs on loose leaf. That's not accurate enough. Also, you're welcome to use Google Sheets or Excel or some other, there's different online things if you're really good with graphing. I'm not going to spend the time teaching that today. So we're going to put, let's see, diameter in centimeters down here. And then we're going to put circumference. And we should put the unit in centimeters on the y. And then we give it a title. The title is always whatever's on the y, circumference, versus diameter. Now, I'm not going to put the numbers in for right now because it's too small. It'll take too long, but you want to put the numbers in. Remember, each box has to be the same. So if each box is 1 centimeter, that's fine. Or if each box is 0.5, your x and y don't have to be the same. I think for this example, they probably will be. So then what you're going to do is you're going to say, oh, okay, for one thing that I did, let's see, the diameter was 2, and then the circumference was whatever it was, maybe up here. And you're going to put those dots in. And they should be fairly linear. But take a ruler when we draw it and try and you say, well, what do I do if one is not on the line? Basically, you try to go through as many as possible. Or if they're a little more scattered, you try to put the same number above and below. But it should be a straight line. Draw it with a ruler or the edge of your book or something like that. And I'm just going to, I have a straight line tool here. Just like that I can use. And like I said, you try to have about the same number on either side. Basically, you're just running up the middle. Now, eventually, you're going to get the slope. So let me change the color of the pen here. I think that might make it easier to see. You're going to pick 2 points. Always try and pick points on the line. So put a point here and a point here. So this will be x1, y1. Oops, that's a bad y, but we'll just leave it for now. Then x2 and y2. And remember your slope formula. And slope is m in the equation, which we're going to look at in a moment. y2 minus y1 over x2 minus x1. And you'll calculate that. And you may remember it's rise over run. This is the run down here, and here's the rise. Just reminding you of some things from math. Now, let's see what that's going to tell us. Remember before I said do not use pi. There's a reason for that. Now, the circumference is pi times diameter. I'm sure we all remember that from doing it in algebra and geometry and all that. We also know that y is mx plus b. We're going to assume b is 0 in this case. And that kind of makes sense, because if you have no circumference, you have no diameter, you don't have a circle. Let's see. Our y-axis was circumference. Our x-axis was diameter, wasn't it? And look what our slope lines right up with. Rm should be close to pi. Now let's say it wasn't exactly pi. Let's say we got 2.9. For our percent error, that's our experimental. The accepted is pi, 3.14. And remember, these up and down lines are absolute value. There's no experiment. There's no negative percent error. So this is how you're going to get your percent error. You're only going to get 1% error. You're not going to calculate pi for each trial. You get pi off the graph. That's the point of the experiment. So what will you turn in? It tells you right here. On another piece of paper, or you can even do it on your graph paper, please neatly recopy the data table. Because odds are when you were doing your experiment, there was some sloppiness. Like I said, I think everybody can do it individually. Everybody should have circular objects at home. The graph, which we just did, and you could do all this on the same piece of paper. Like if you drew your graph and then you have room below your graph, you can put your data table, no problem. Your slope calculation and your percent error. And just a reminder, if you used an English ruler, maybe all you had was a tape measure around the house or like one that you use for sewing, absolutely fine. 1 inch is 2.54 centimeters. So you will need to do that conversion to move it over into centimeters for when you do your graph.